So in this segment we are going to see different type of functions. We have actually two type of function, which is surjective or onto function, injective or one-to-one function. So let's see example. So first we are going to see a surjective function, or the process is known as surjections. Okay, so a function is a surjection, or a function is known as a surjective function if and every output is possible. Okay, so for every element of B, okay, so just be careful, how I am reading these donations here, reading these notations here. So here I am using some of the quantifier here. Just recap, it is known as for all, and this one is known as there exist. So just look at that, how I'm reading all these notations. For all B, or for every B belongs to B, okay, there exists A belongs to A such that f of A equals to B. All right, so here you can see that I have a target domain here. I have a target here B. Okay, so this is our input domain A. So here I have actually in the target and in the mapping, f of A mapping, you can see that every value, for every value B, every elements B in this set, okay, there is actually some value, some elements in the A. All right, there exist some elements in the A such that f of A results to the elements from the B. Okay, so this is known as surjection, means for every output, okay, for every output is possible. So informally we can say that every output is possible. Every output will be mapped by some input. Okay, every output will be mapped by some input. All right, so let's just give you an example. Say we have 1 2 3 and B is x and y. Okay, now I have f equals to 1x, 2y, 3x. So in the target I have x and y. So in the ordered pairs of f, in the set of ordered pairs, I can see that every output I have actually every output here is present. So I have x and y. Okay, so for x there is input possible 1 and 2. If there is at least one input is possible, that means for every output, I'm sorry, so for every output there is at least one input is possible, that means it's a surjection. Okay, now here we are seeing that as for every output there is a input possible. Okay, so the number of elements in the set B will be actually less than or equal to the number of elements in the set A. Okay, so here actually I'm going to ask you, it will be interesting to try to make a counter, try to make a different example. Try to have something like f where try to make something like that where the number of elements B is higher than the number of elements A. Try to prove that whether surjection is possible or not. For example, like that. Okay, and try to make it like B, say x, y, z, p, q, r. So do you think it is possible to have a surjection? Injection. Injection says that, informally injection says that no two input have the same output. Okay, every input will have exactly okay, so no two input will have the same output. It is saying that no two input will have the same output. Every input will have a every input will have a different output. Okay, that's what it is saying. Say for example here, this one is mapping this one. You can see that. How we'll understand that? So when I have the set B, so for every elements for B I have actually less than or equal to one arrow. Okay, so there are some elements who doesn't have any arrow, means there are some input who there are some input who doesn't map to any elements in this B. Okay, so first let me ask you, is this a surjection? From this figure you can see that, from this figure do you think is this a surjection? No, because there are some elements in B for which we do not have any input element from A. Okay, now injection says that no two input will have the same output. Okay, so for every output you can see that there is exactly one input. For every output there is exactly one input. Okay, for every output there is exactly one input. All right, so for the B set, for every element of B set, you are seeing that there we have less than or equal to one arrow here. Okay, so we are not going to have something like that, okay, this value and this value cannot have the same output. This will not be possible in the injection. Okay, so how we are going to read it like that? For every A and A prime, okay, for every A and A prime both belongs to set A, if we have the case like f of A equals to f of A prime, that will be possible only if these two values are same. Okay, so if this f of A equals to f of A prime, that will be only possible, that will only denote that these two value A and A prime equals to same. Other than that, if A not equals to A prime, that means f of A is not equals to f of A prime. Okay, for any two values, okay, if they are different, their output will be also different. Okay, so in this example the number of elements in A is going to be less than or equal to the number of elements in B. Okay, so another type of function known as bijection, if the function is both surjection and injection, means if this is both surjective function or injective function, then this is known as bijection. Okay, so you can see that here actually for every input, okay, for every input is mapping to a different output. Okay, and from set B you can see that for every elements in B there is an input from A. Okay, so in that case, okay, exactly one arrow, so every elements B has exactly one arrow. So here we said that less than on one arrow, because here we have some elements in B, it doesn't have any arrow. Okay, it has zero arrow. All right, but here for every elements of B will have exactly one arrow. Okay, it will not have two arrow or it will not have zero arrow. If the arrow is zero, okay, that means it's not a bijective. Okay, if the element is zero, that means it's not surjective. Okay, so if the arrow we have zero arrow, that means it's not surjective. Okay, if greater than 1, okay, means not injective. All right, if greater than 1, that means not injective. So there is going to be exactly one arrow to every element of B. Okay, and from the function definition we know that there has to be every element of A in the function. Okay, and in this relation, if the function is bijective, in this function, the number of elements of A is going to be exactly same as the number of elements from B. Okay, now let's find out whether this one is 1 to 1 or on to. Okay, we have A 1 2 3 4, we have B x y z. Okay, so we can write that, we can show that like that, and we have x, y and z. So the mapping is like that: 1 to x, 2 to y, 3 to z, 4 to y. So is it injective? No. Why is that? Because 2 and 4 both are having the same output. Okay, f2 equals to y and f4 equals to y. All right, that is not possible. So that will be only possible if a1 equals to a2, means here no two input can have the same output. Okay, no two input can have the same output. All right, so this is not a injective. And from the arrow you can see that here we have more than one arrow, means it's not injective. Okay, now it is a onto. Yes, there is actually an arrow for every element in B. Okay, there is an arrow for every element of B. So this one this one is onto or surjective. Okay, so yes. Now let's draw that. We have 1 2 and 3. Okay, and we have x, y, z and w. So the mapping is like from 1 to w, 2 to y, 3 to x. Okay, all right. Is this injective? So here the number of arrow, you can see that for every element in the B, number of arrow is less than or equal to 1. Okay, number of arrow is less than or equal to 1. So this is injective. This is injective. It actually you can see that for every input has a different output. Okay, no two output has the same input. All right, but is this surjective? No, because there is actually some element z. For z there is no a that belongs to a. Okay, for the element z in B, the number of arrow is 0. Okay, it doesn't have any input. So surjective says that every output is possible, every output has to be there. Okay, so z is not there, means it's not surjective. Okay, all right, so that's your home exercise. Try to do that. Okay, I will talk about that in the next class.